So in other words, they are giving us the limit already. So it's like, oh yeah, like restricted. Well, I'll try to explain it as you move along. But here we kind of guided what are the limits to work with. Now, if I check under my the area under my curve, those limits are actually at the bottom here. Right? We've got it's from 0 up to A. What does it tell me? It tells me the position of the stripe, the position of that differential element which I need to work with must move from 0 to A. So meaning I need to position that my differential element vertically, right? So that is the piece which I'll work with. So that's my differential element, right? So meaning if I move it from 0, or based on the instruction which I was given, I have to move from 0 to A in order to cover the entire area, right? Procedure-wise, first step, position your stripe. In this case, that's the position we need to go with because we are restricted in terms of which limits to work with. Next step will be that stripe is some kind of center, right? So now the next thing to do will be, can you try to size your differential element? It looks like a rectangular. Can I give it some dimensions? That's what I'm referring to. Let me call the thickness of my stripe or differential element as your dx. Why dx? Because it sits on the x-axis. I don't want to give it a value. I'll call it just dx. Let me call the length of my stripe, right, y. Why do I call it y? Because I want to relate it to my y-axis because it's parallel to y-axis. That's why I call it y. Right. Next will be, let me look into those perpendicular distances. Right. By definition, your x perpendicular distance is from the centroid, right, up to your y-axis. Right. The second one, your y perpendicular distance will be from the centroid up to centroid of my stripe. Let's not remember, forget that. I'm referring to the centroid of my stripe. It will be from the centroid up to x-axis. Right. So let me divert into my table cam, and then you'll take it from there because there are a couple of writings which need to be done. Just give me a sec for me to switch to my table cam there. Oh, do I have? No. Yes, I see a hand there. Go ahead and ask your question. This is Nakin.
All right, then just say I'm still trying to digest what you have said right now. Now
Yeah.
I would like to ask how is it different from the composite one, because I can see we have the center of the centroid there as well. How is it different in general?
Remember, the question is it's not really different, but here we're trying to get the centroid based on the first principle. By first principle, it's applying the equation, the definition of the the equation which governs those coordinates, and then apply your integration. By doing it from first principle, you'll end up, I don't know if you've had a chance of going through that formula sheet. Have you used the formula sheet so far?
Yes, that one of mathematics.
No, the formula sheet from mechanics.
Oh, page 200, on the last pages.
Yeah, but let me see if I have it somewhere here. Well, you like, yeah, I think I have it. Oh, I just wanna, well, while we're talking about it, let me just start here. Right. So you have this formula sheet, which I believe everyone has come across it, right? So now, if you check on this formula sheet, you see the centroid column there. You've got some kind of equations. So these equations, they've been derived from what we're doing by the differential element method, what we're doing with through integration, blah, blah, blah. If you use that method, we'll come up with, that's how these equations were obtained or derived. So what we're trying to convey is how do we go about reaching to these equations, right, from first principle. So one need to be aware of that as well. Because if you're aware of that, you'll be able to deal with any type of area, regardless, it might be on the this formula sheet or not. But as long as you understand, you understand the approach to it. Oh, where am I? I've jumped to my, as long as you understand, oh, can you still see my, oh no. I'm trying to share my screen here, right? So one need to be aware of the way you should go about reaching to these formulas. So knowing that you can deal with any type of area or volume you can come across. It might be on this formula sheet or not. But as long as you know the how to go about getting those equations, how to go about getting the two coordinate, that's what we're trying to pass. That's what I'm trying to convey here. I've seen there was a hand. Oh, what happened to the hand? Well, anyway, was that a question or not? Well, anyway, let me go back to my cam and then you can take it from here. Maybe by doing an example, that will start kind of sinking in. Just give me a sec here. It's like I have two things which are open. I believe you can see my paper there, right? Can you see my paper?
Yes.
Oh, please say something. I'll quickly try to redraw that area we're dealing with. So I've got my X and Y, and then I've got my curve, right? On my curve, that will be my limit A, 0 to A, that will be B. And the function was X equal to KY cube, right? If I'm, yeah, I think I have. So now what we've done so far, you choose, position your stripe. In this case, we're limited. So we work from 0 to A, meaning I'll position my stripe vertically, right? So having my stripe vertically, I'll define it in terms of thickness and length, the size. So my thickness will be, I'll call it dx. Gave you the reason why, because it sits on the x-axis. The length of my stripe, let me put it down, I'll call it y, because I want to relate it to my y-axis. Parallel to it, that's why I call it y. and dx, the base or the thickness of my differential element or area, right? My differential area has its own center, right? So now let me define the different those perpendicular uh, distances. By definition, my x perpendicular distance is the distance from this the centroid of my stripe up to y-axis. In other words, this is my x different distance, perpendicular distance. My y perpendicular distance is from the centroid of my stripe or differential area. How far is it from my x-axis? So that will be my x, my y perpendicular distance. I would like to name it yc, just to avoid the confusion between the two y's, right? So that will be my second perpendicular distance, right? So now looking into that second, my YC, I can actually quantify it. So my YC will be actually Y over 2, right? If I have to quantify that, it will be just half the length of my stripe there, right? So now, if I look into, but this is more of trying to, if I look into my function, I can actually quantify the value of k there, which is a constant. So your k will be x over y cube. So now I can actually solve it in terms of what is x, what is, what is x, what is y. X, it's about, it's a, right? So this will be equal to a over b cube, because I have my a and b on the side. I can actually quantify the value of my constant k, right? So once I'm done with this, now I'll look into those equations. Let's start with my x bar. By definition, it will be integration of x d area over d area, by definition. So now I can couple or include my limit already. In order, but now one way of finding out the limit will be if I position, in order for my stripe to fill up the whole area under the curve, my stripe has to move from 0, right, up to A in order to move or to kind of fill up the whole area. So my limit in this case, this is one way of finding that up or finding that out. So it will be between from 0 to A. Those are my two limits, right? So now let me define the area. Which area am I talking about? The area of my stripe. I can actually quantify that. It will be the area will be the thickness of my stripe times the length. So it will be y dx, right? So now let's look into the equation. I think, I always try to advise students to do it separately. By separately, I'm referring, can you work out the numerator first and the denominator separately? And at the end, it will be a matter of taking your numerator over the numerator, and then you get your coordinate. So let's look into your numerator first. So my numerator will be, where do I put it? Well, let me put it here. Integration of x d area within my limit a and 0. So what is the area? I've defined it there. I'll take it and put it in here. So this will give me integration of x times y dx within my limit. Right. So because my integration is being driven by the x dx, so having y, I cannot solve it. So I need to change the y into x. How do I do that? I go back into my function. Can I express my function in terms of y and come and replace it here? So by doing so, it will be integration of x times, if I have to express that in terms of y, so that will be x over k exponent 1/3 dx within my limit. Are we on the same page there? What I've done just to change the expression of y out of my function and replace it into my integration there, right? So now I can move out or remove my constant. Remember, my k is a constant. I can remove it out of my integration. So it'll be 1 over k exponent 1/3 integration of x times x exponent 1 over 3 dx within my limit, right? I'm sure we can work that out, right? So it will be 1 over k exponent 1/3. Well, let's go step by step. Integration of x 4 over 3 dx. So I can now solve my integration, right? I believe, I'm not sure how far you with your integration. So it will be 1 over k exponent 1/3. I can solve this as, well, I don't know if you've done it already, but I can explain how to solve your integration. If you check your exponent, 3 over 4 over 3, to solve it or to solve your integration, you need to add +1 to your exponent. This will give me about 7 over 3. And take that answer here, come and divide it under your x, right? You divide it over 3 over 2, which is the same as multiplying by 3 over 7, right? So to expand this, this will be, in terms of solving, 3 over 7, right? X exponent 7 over 3 within my limit, right? So the k value, I know how much is it because I've got it somewhere here. So it will be a matter of replacing it here. So this will lead to b cube over a exponent 1/3. Or should I? Oh, let me just push them 3 over 7. Just want to put it in front. That will be, I don't know if I should solve it already. It will be a exponent 7 over 3, right, times this. So this will lead to 3 over 7 b, should you put ba, sorry, ba, this will be square, right? Do we understand? If I multiply these two, it will be b exponent 1, these two. These two, it will be 7 over 3 minus 1 over 3, which came from the a here. So that will give me the square part, a exponent a squared. Well, that makes sense, right? Well, that makes sense or not? So I've worked out my numerator. Let me look into my denominator. I'll just switch the page here. With my denominator, well, too many pages. So it will be integration of the area within my limit. Now, what is the area? I've defined it as y dx. So it will be integration of y dx within my limit. So I cannot solve it there. I go back into my function. Let me express it in terms of y. So it will be x over k exponent 1/3 dx within my limit. So my constant, I can take it out of my integration. X 1/3 dx within my limit, right? So which takes me to b square or b cube over a exponent 1/3. I just replace the value of k by what it is. I can solve my integration. So it will be plus 1, your 1/3 plus 1, which will gives me 4/3. I take this and put it at the bottom, right? Which is the same as multiplying when you flip it. So by flipping it, it will be a 3/4. Should you say x 4/3 exponent 4/3 within my limit a and 0, right? Um, are we so far so good? I guess, yeah. So this will be b cube over a exponent 1/3. I can put my 3/4 in front, just push it in front, which will multiply. I can replace my x with a when I resolve, my integration. 4/3, right? So which takes me to 3/4. This will be b, right? Exponent 1. And that will be a exponent 1 as well, because this will be 4/3 minus 1/3, which is 1. So be exponent 1, exponent 1. So that will be the denominator, right? So to be a matter of now taking your numerator over the denominator in terms of your x bar. So it will be 3/7 ba square. You divide the whole thing by 3/4 ba, which talks to 4/7 b. So that will be my first coordinate, x. Are we getting the steps? Or is there somewhere or somewhere you got lost? If that is the case, let me know. We can always go back and look at it. So that's how I've defined my first coordinate, your x bar. Now I can look into your y bar, right? Based on your, by definition of your y bar, it's integration of yc. I want to put the yc to avoid the confusion which I've mentioned there. Yc d area over d area. Now remember, d area, we've worked that out already when you were working out your x bar. So we'll just use the value of integration of d area. So now can we just work your numerator? So your numerator will be integration within the limit of yc d area. Oh, d area, yes. So now let's look into those definitions. What is yc? It's y/2. What is d area? It's y dx. So this will translate into y/2 times y dx within my limit, right? So which will be 1/2 integration of y squared dx within my limit, right? I'll just multiply this. So now I can't solve it here. I need to go back into my function to express that function in terms of y and come and replace here. So this will be 1 over 2 integration of x over, what am I? Yeah, x over y cube. Oh, is that right? No. What am I writing? It should be okay there. So y cube will be x over k, right? The whole thing exponent 1/3, right? So that will be the y out of my function, but I need to square it, right? Dx, right? So this will be 1 over 2. Let me put this in a proper way. I want to remove the constant out of my integration, right? Times 1 over k exponent 2 over 3. Then I can put my integration as x exponent 2 over 3 dx within my limit, right? So one can actually solve that. So this will be 1 over 2. This will be b cube over a, the value of k, right? Exponent 2 over 3 multiplied by. Now here, remember what I said. If you look into your exponent, plus 1, this will give me 5 over 3, and I take it and put it at the bottom. Or I can multiply it by flipping it around, right? So that will be multiplied by 3 over 5 to be x exponent 5 over 3, right? Within my limit, if I should put it, my limit, which is a and 0, right? So to be 1 over 2, or should we say 3 10 over 10, I just multiply those times. Now let's look into these ones. B will be b square, right? If you look this, now I'll look into these two, right? That will be about a. Be on the same page there, right? So I've just replaced my x by a. Here it's 2 over 3 to be minus 5 over 3 minus 2 over 3, which gives me exponent of 1, right? So that will be my numerator of your y bar. Denominator, I've got it already. Just need to look, where is it? Your D area, it's round about there. So your y bar will be this numerator, right? B square A over your denominator, which is 3 over 4 BA, right? So which will do like this. It will be 4 over 10 B, or 2 over 5 B, right? So that will be my, oh, this is B, not 5, right? Let's just, right. So that will be my Y bar, all right? That will be my Y bar. So I've defined my X bar, right? Oh, my X bar is here, and my Y bar will be this one. So those are the coordinates which they wanted me to quantify or to work out from first principle. Any question on this? Any question on this? I would like to emphasize on the steps to be taken. Where do you start? Start defining or positioning your stripe. Out of that stripe, can you size it up? By sizing it up, I'm referring, can you give it some kind of dimensions? In this case, it was the thickness. Let it be dx if it sits on x-axis or if it is parallel to x-axis. Let the length be y because it's parallel to the y. You don't want to give it a value, right? Define the two perpendicular distances and then look into the equations which governs those coordinates and replace them accordingly as you've done it. Your D area must be defined based on the dimension you've put there as you've done it here, right? So once you have these, my advice would be calculate, work out your numerator separately and then your denominator at the end, you've done just the way we've done it uh, roundabout. Oh, somewhere here. You just take your numerator over your denominator, you work it out. But in the book, sometimes they work them at the same time. If you are comfortable of using that method, please go ahead and do it. Otherwise, well, use the one which are just the method which I've explained. I think just to avoid confusion in there. Right. Any question on this?
Yes, sir. Sir,
Yes. Mm.
what if your shape? What if your shape has no function? How are you gonna find the function of the shape? If let's say like this one, it's given as x is equals to ky squared.
Uh,
What if
okay.
it's not given? Say, how am I gonna get there?
Most of the time it is given, but sometimes they assume that you know. Let's say like the equation of a straight line, right? An equation of a straight line that they assume that you know, but I believe you should know that. But most of the time, the curve, the function, the equation of the function is provided most of the time. All right. Will that answer your question?
Yes, sir.
Yeah.
But then, sir,
Mm.
why are we working with variables instead of like working with numbers? Why instead of like working with a and b, we work with two and three? But it's gonna be easier that way. Sir. Unlike working with variables, just mess up everything.
No, it shouldn't be. It shouldn't be. If now, let's say they give you values or from here to A equal to whatever it is, 5 or 10, in your answer, you just come and replace them there. Mm. In your answer, you just come and replace by what they are, and then you get your answer. So this is like, it's, I don't want to say generic, or I think the general way of doing it. But if they give you values, you can just come and replace them into it. What is B? What is A? You put it there, you get your answer. That shouldn't be a big issue out of it. All right.
No problem. Sir. Say
Okay.
like
Mm.
on
Mm.
your sample examples, the first one that you show us, there was a z-axis. Are we gonna work with 3D?
No, we'll stick to 2D,
Okay.
right? We'll stick to 2D. The reason why I'm bringing the Z axis for you to be aware of it, because you don't want to come one day to a situation where you say, can you consider the Z axis? Then you don't know what to do. No, by talking about it, just to make you aware, say, no, you can as well do it. But in this case, we are limited to the X and Y, your 2D projection. But it doesn't mean you cannot do the 3D. That's why I'm bringing that aspect, especially if you have to deal with body, like if you have to talk to volume, mass, then you have to bring the three Cartesian or the three coordinates there, right? So for you to be aware, so, oh, I can still handle the 3D, even though I'm looking into 2D, but I can still handle the 3D as well. But for the scope, our scope, we're looking into the 2D only. All right.
Yes. So it means that we're gonna work with the area or the area only, not the volumes and the
Then
other
you
ones
did.
that we saw.
It shows me you didn't listen to what I was saying. Remember when I was going through the different differential element? We've mentioned mass, weight, mass, volume, line. Then I told you, say, no, our focus will be on the area. So we'll work with the areas. But let's not limit to the areas. You can look into other differential element as well. But for us, for now, we're looking into the area only. That's what I said. Okay.
Yes, sir. Thanks.
Right. So now, sometimes
So,
you might.
sorry, sir.
Yes.
Sorry, sir. Yes, sir. I have a question, sir.
Go ahead and ask your question.
Yes, sir. Since you are the examiner or Mr. Sulua, and you actually set up the tests or exam, are you going to give us a problem that already has a formula or equation to the problem, or will we have to find out?
Now, what do you mean? Or are you referring to, like, if you look into this sample problem, are you referring to the function of the curve?
Yes, yes. Are you actually like going to give us a function, or will we have to work it out? Like I see that problem, the eighth one, the problem from eight from the textbooks, where we had to find our own equations. Yes.
No, that's what I was saying. It depends of which that most of the time you'll be given, but sometimes they assume that you know. Let's say the equation of a straight line. Who doesn't know the equation of the straight line? So it doesn't mean they'll give you the equation of the straight line. No, you can derive it yourself.
Yes, I understand. It's just that since you are the examiner and you set up the papers, I'm just asking, will you give us a problem that already has a function or not?
I'll try to look into that one to give you something which you can work with.
Thank you, sir. Thank you very much.
All right. Is that Lavi? Is that?
Yes,
Okay.
yes, sir.
Right. Any other question? But I want us to look into the case where if we are not restricted. Restricted in a sense of if I have to change the position of my stripe, how will I go about working out those coordinates? I'm trying just to bring out my slides here. So regardless which position you use, you should get to the same answer. I just want to share this. Let's now check this case, the second case, where someone else might decide, I would like to position my differential element horizontally, right? Oh, am I running out of this? So regardless how you position it, you should get the same answer. You should get the same answer. So what one need to do here is let's stick to the definition of certain things, right? What are those? Right. If we position our stripe this way, horizontally, there are certain things one need to be aware of. One of it will be how to define those perpendicular distances, how to measure them. That's what I'm referring to. By definition, your x perpendicular distance. Here, they would like to call it xc just to make it, not to get not being to clear up the confusion between the x's. They don't want to call it x as well. So because it's that distance, let's call it xc. Right. By definition, is the distance from the centroid of your stripe up to y-axis. That's the definition of it. The y perpendicular distance is the distance from the centroid up to x-axis. Right. So now when you position your stripe horizontally, the first step will be, can I give it some size or the dimensions? I'll call the thickness of it dy because it's parallel to y-axis. Right? The length of it, I shouldn't call it x. The reason is because there is a shortfall, because my stripe does not touch the y-axis, right? Let me call or name that shortfall, that short distance, let me name it x. By doing so, I'll be able to bring out or work out the length of my stripe. So if I call that shortfall distance here, x, so the length of my stripe will be a, which is my distance at the bottom, minus x, that will give me the length of my stripe. Right? So now to work out my d area, so it will be length times thickness. So a minus x times dy. Right? So let's be careful about that. So now once I have the length of my stripe, I would like to look into that perpendicular distance xc. By definition, is distance which goes from the centroid up to y-axis. So how do I quantify that distance? So now knowing the length of my stripe, if I divide it by 2, I'll have the distance which goes from the centroid up to here. That if I add x, I'll reach to y. That will define my distance xc. Are we on the same page there? Do I have someone who didn't get it? How to work out your xc? We stick to the definition of it. Are we clear on that?
Yes, sir. Yes.
All right, okay. I'm trying to insist on these because we need to make sure. If you don't get it right, I just stick to the definition, what they are, and bring out their distance based on the dimensions which you have. All right. I'll probably switch again to my cam. Then we'll look into this one. Just give me a sec. Let me share this. Oh, okay. You can see my screen, right? Oh, sorry. Some control. I believe you can see my paper, right? So that will be my area, y and x. That will be my function, define as x equal to k y cube, and I've got my limit a and b. Now this time I've decided to position my stripe horizontally in that manner there, right? So let me size it. Thickness will be the dy, right? The length of my stripe, because of the shortfall, let me call this x, the distance there from here to here. I have a, so this will be a minus x. That will be the length of my stripe, right? My stripe has its own centroid. The distance from the centroid up to, that will be my yc, that distance, right? And the distance from here to there, that will be my y, my perpendicular distance, right? What I know k was in terms of value, it was a over b cube, right? If I have to replace it in there. So now your yc, that's perpendicular distance. What I said, it will be your xc, not yc, your xc, right? What I said, it will be, if I take the length of my stripe, I divide by 2. A minus x, I divide by 2 plus x. So that will be x plus a over 2. Right, so that will be that perpendicular distance. Right. Next will be, let me write down those equations. X bar will be integration of x. I want to write xc just to get the difference. Xc, the area, over the area, right? Let me define the area of my stripe. It will be length times thickness. So it will be a minus x dy, right? So let me start with your numerator. Integration of now xc. What is xc? I've got it here. So it will be x plus a over 2, which is my xc, multiply by the area, which will be a minus x dy. So now in terms of limit, I'll use the same approach. In order, if my stripe is horizontally, in order for me to fill up the entire area, that stripe has to go from the bottom up to B, from 0 up to B, because my B is the maximum there. So it will be between from 0 up to B. Those are my limit I need to work with, right? So now I tackle the integration part. So it will be, you multiply, well, let's sort out this side of the integration. So this will be, I'll try to, so it will be ax, where am I? Ax plus a square over 2, right? Minus, what am I? What did I do? This, that, yeah. Minus, now looking at the x, to be x square plus ax. Oh, did I do it right? Where am I? So I multiply each one by the term there, right? That's what I'm trying to do. Ax squared plus a over 2 dy. Right, I can put this bracket here. Is that, will that make sense? Yeah. What I did is just to multiply my x to each one of these terms. Right. So now you can expand this. That will be, I just want to split them because I can apply integration on each side. So it will be integration of ax plus a square over 2, should I put dy minus integration of x square plus a, well, we're not jumping really in the mathematics class, isn't it? Right. So I can, you know, filter my integration in each one of these and it will be that long one. So it will be integration ax, let's say 2. Oh, let me remove my constant and put it in front. So it will be ax dy plus integration of, oh, should I put a square dy, all right, minus, we can take that out as well, integration of x squared dy.
Sir,
Yes.
before you continue, what are you integrating with respect to?
Oh, with respect to the dy.
Oh, okay.
Yeah, I'm trying to open up first these brackets, then I'll go into changing all the x into y based on my function, and then sort it out.
Okay, sir.
Right. I know it's a long process. There will be, I'll go up to a certain level, but let's filter the integration first. Right. Where am I? Yeah. Plus a x dy. Right. Are we making sense what I've done here? I just apply integration. Well, I took out my constant out first and then apply integration on each one of these. All right. So am I running out of space? But 1/2, I'm going now into each one of these integration and rewrite them. I don't know if I should solve the, oh no, let's go step by step to be a integration of x dy plus a square integration of dy minus 1/2. Well, now, should I solve it already? Well, let me go step by step. And now x square dy plus a integration of x dy. Right. So now let me do away with all the x in the process. So what's my relationship here? X equal to k y cube, right? So let me replace all the x with ky cube. 2 ky cube dy plus a, this one I can solve it already. That will be times b, right? Because there is 1 there. If I have to do my integration, it will be equal to b because my limits are from b to 0, right? So this is sorted, right, into minus 1/2 going on the other side. B x will be ky cube square dy y plus a. Integration of that will be ky cube dy. Are we on the same page so far? Or are you with me, or are you still there, or not there anymore?
Yes, sir.
Okay. So let's, that should be a, right? Let's try to solve the integration. So to be 1 over 2 a, let me solve, ak, right? My constant, I've pushed it out. Let me solve this already. That will be y4 of y exponent 4 over 4 within my limit to b and 0. Somewhere here, plus this, I've worked that out already, minus 1 over 2. Let's work out this. Oh, yeah, the integration is missing here. So the sign of integration is missing here. So this will be, let me push my constant out. So to be k square. Should I solve it already? It be y 7 over 7 within my limit b and 0, plus here it will be a k, right? I can solve it as well. To be y4 over 4 within b and 0, right? But now, let me consolidate what's in the bracket. A k, the value of k, remember it was a over, we've got it somewhere here, the value of k. So it will be a square over b cube. I'm trying to work out this one, times b4 over 4. All right, let me put this in the bracket, plus a b. That will be into a over b cube, which is k, which I need to square, right? That will be b7 over 7 plus this will be a square over b square, b cube, sorry, b4 over 4, right? So this will give me 1 over 2. So this will go away. A b over 4 plus a square b minus 1 over 2. This will be, what am I? This will be 6, right? It will be a square. This will be 1 b over 7 plus a square b over 4. Are we on the same page there?
Yes, sir.
Oh, okay. Which tells me this will cancel that one, right? So it will be a square b over 2 minus a square b over 7. Oh, 14, not 7.
Would it be 14, sir?
Sorry,
No, no, I see you fixing it. It's fine.
it's 14, not 7. I forgot
Yes.
about the 2 there. Right. So that will be your numerator, isn't it? Right. But obviously, one can continue from here. A common denominator and blah, blah, blah. You get, I don't want to go too far. Or should we go too far? But you can do that. So this will be your numerator. So now I need to look into your denominator, isn't it? Your denominator. Do I still have papers? Oh. So into your denominator, remember it was integration of D area. And D area was, let me put it here. It should be integration of D area, you've got it there. A minus X dy, right? So within my limit, Bn 0, right? So I'll have integration here minus the integration of that. So to be integration of, A, I can put it out, it's a constant, dy minus integration of X dy between my limit, B and A. So I need to do away with this by looking into my function. So this will be A. Let me write it first. I'll change everything. Bn 0 minus X will be integration of, or should I put the K outside? Y cube dy. Right, now I can solve it as to be AB minus, remember your K, it's A over B cube times your B 4 over 4, right? So this will do away. So this will be A B minus AB over 4, right? So yes, get the common denominator, and so now at the end of the day it will be what is this numerator divided by this denominator to get out, or to get your X bar, right? So one can actually pick up that when you position your stripe horizontally, you have this long calculation, this long integration to work with, right? So it boils down to doing the integration. As long as you apply the right variables, right, in terms of those perpendicular distance are being defined properly. Now it boils down to just do your integration. Right, so one can now move into the y-axis, so you do the same, right? With your y-axis, I can just give you an int. So we said it was yd area, your numerator, well, over the, well, that's your equation in terms of y bar. Integration of your d area, we've done it, that's the one there. So to be a matter of just placing it here. So you don't need to go and rework it, but work out your numerator. Your numerator will be y the area being a minus x dy, right? Then you multiply your y right through, apply your integration. So it will be a integration of y dy minus integration of x y dy, right, between your limit. Are we on the same page there, right? And this will be, now we need to do away with the x. What is x? We go back into your function. So to be a integration of y dy between b and 0 minus integration of x will be k y cube. So to be ky 4 dy, the second one. I guess you understand here. Your x, it's ky cube based on the function. That's what I've replaced it here. So this will be, I can solve it already. That will be b squared over 2 minus, this will be a over b cube, right? Times b5 over 5, right? So this will be, oh, did I do the right thing there? K, it's a over b cube, right? I've replaced it there. It's the constant which I've pushed, and then solve your y exponent 4, integrate it, gives me this. So one can actually do this, 2 and 2. So it will be ab squared over 2 minus ab squared over 5. Right. So that will be your numerator on the y bar. Yes, let's go and get the common denominator. We get something there. All right. It will be this over that to give you your y bar. That's what needs to be done, by the way. That's any question.
So do you have the value of x bar?
Oh,
Like at hand?
the values, we've got them in the textbook. Where are we? Let me, your x bar, or should I write it? Your x bar, it's equal to 4 over 7a,
Okay.
right? And your y bar, it should be about 2 over 5 b, something like that.
Okay, so no, it's fine.
Yeah.
I was just
So you've
confirming.
got them in the textbook there. All right. Any question on this? So what I want you to do, go through that sample problem in your textbook based on what we've done today. Check if you'll get the same answer. Change the position of your stripe. You should get the same answer. If not, check where did you go wrong. So once you understand these steps, the rest becomes easy. So regardless which shape you're dealing with, you stick to the same steps which we've done today, you should be able to get those coordinates. All right. Any question? I think I'm done for today. I'll stop. So it's a matter of going and start practicing. And then as time goes by, there will be certain problems where they've combined, or they ask you to work out the centroid of an area which falls between two functions, right? So there are problems which are related to that, but you'll address them. How do we deal with such problems? If your lamina is the area of your lamina is defined between two functions, how do I go about getting those coordinates? It's not rocket science. We'll just apply what we know. All right. Any question? Yes.
Sir, this is not about today's class, but thank you so much for today's class. Regarding the test that will be written next week, have you confirmed whether it's going to be the Friday or the Saturday?
The semester test will be written on Friday.
Oh, okay, no problem.
Yeah, based on the stats or the choice of the majority of the student. I'm not. Yeah, I'm not sure if with regard to the class test. Are you ready?
Which class? Okay, I don't know anything about a class test, but
Class rep, where are you? Is the class rep on the platform?
Yes, sir.
Oh, are you aware of the class test?
Yes, sir. We discussed it in last class.
Okay. So that will be on Monday after 4. Are you attending something after 4 on Monday? Online, by the way, it's a kind of a class test which will be done online on the second part of chapter 5, your composite areas.
it's
All right.
only just composite areas.
Yes.
It doesn't involve this integration.
No, not yet. But that one is only the second part, which is composite areas.
No problem, sir.
Okay. Yeah, that's if there are no questions. Yes.
I wanted to ask how many semester tests before final exam?
The semester tests, we need to do about 3 of them. So that will be the second one, and the last one is still coming there.
The last one, when do you think we're going to write it?
We need to do it before December. We need to do it before December. Yeah.
Thanks.
Okay. Any
So
other
just
question?
do you mind confirming the semester test scope, the upcoming semester test?
Oh, I've mentioned that in the announcement, isn't it? So that will include chapter 4 and the second part of chapter 5, your composite. Well, chapter 4, it will be, sorry?
The semester test as well does not have the first part of the composite bodies.
No, it does not.
Okay, no problem, sir.
Yeah, we'll stick
Then
to.
chapter 4 will be everything, even machines.
Yeah, there will be a question on frames and machines, frame. Oh, I mean, method of. Where are we? Section and joint. Oh, are we? Yeah, section and joint. So there will be a question from each one of those areas.
So basically, there'll be 3 questions from chapter 4 and maybe 1 from chapter 5.
No, 2 questions from chapter 5.
Okay, sir, no problem.
Okay.
Thank you.
All right. Oh, there was something which I would like to raise with you in terms of we need to agree to certain things in terms of protocol. If anyone has an issue with any area of the subject, I think we need to all adhere to some kind of protocol. I'm referring to if a specific student has a problem or an issue, can that student, let's follow the protocol, meaning can you speak to your class rep, raise it to your class rep. If the class rep does not respond, then go through your lecturer. If you're still not satisfied, then you can go to the HOD. If you're still not satisfied with the HOD, you can go to the dean. So that this is the protocol. I think, well, it was being made as a way that there were students who, I don't know, they had issues, whatever it was, and went straight and talked to the HOD, say, well, we can't do things this way. We can't work that way. Let's follow the protocol. Let's get help. Where if you are struggling with something, I always say, with my student, if there is something which you are not clear about, talk to me. I'm open. Come, if you can't come straight to me, start with your class rep. Let's try to follow the protocol, not jumping the queue because you know or you can go through certain doors and then you just jump everyone. That's not the way of the right way of doing things. All right. And I'm not sure how many times did I repeat this. I don't know. Let me say it again. You guys are exposed to both of us, right? By both of us, I'm referring to me and Mr. Siloa. My recordings are available to you. His recordings are available to my student as well. I always tell my student, because I deal with industrial and polymer student, if there are area which you might struggle, when I explained it, maybe if you hear it from the other lecturer, it might, make it easy for you. So you are all exposed to what we do. And maybe sometimes start taking that, effort to go and check, oh, there is this area which maybe I'm not getting the point or the concept based on what my lecturer is saying or have done. How about I go into the other lecturer and see what is it that they've done on the same topic? So you have these options. I don't know if how many of you have tried that. It's a matter of going on what's this? On Brightspace under those recordings. I have my recordings which I do for all my session, and Mr. Silo, I believe he has his as well. So you can go there and check. And on top of it, you have additional resources which are available on the Wiley Plus resources. If you're struggling with certain concept, we do have some videos on that platform which you can go and watch to make sense of that. I don't know if you guys are aware of all these things. There are a lot of resources, information on Brightspace which you've put there. Maybe it's just a matter of taking some time to go and see what's on there. Maybe that could be the solution of a specific area you're struggling with. There are additional information and videos, animation as well, to explain certain concept. If you're struggling with, it's just a matter of go on the Wiley Plus resources. You have all of those stuff, right? So the point which I was trying to cross was the protocol. Usually does not sit well with me. Let's have a discussion. Let's adhere to certain rules, and then, so if you start jumping the rules and, because Mr. X, let me go straight to Mr. X. Let's follow the protocol. That's what I wanted to relate to you, but it came to my attention, and usually I don't like that. Talk to us. If you have a problem, talk to us. I'm sure we are open enough where we can engage and see what's the best way to do things. If whatever we're putting on the table does not work for you, instead of jumping the queue. All right. That's my message. And if there are no questions, have a good one. It's a matter of practicing. That's how you'll get these things. Unfortunately, you have to do more problems. The more problems you'll do, that's how you'll get the concept. It's not one. And I always don't believe in the thing of these are the problems to do and these are the solution. I don't think that's the best way to learn. Put your mind to it. If you struggle, identify which area you're struggling with and then seek for assistance through us or through your classmate. That's why I always try to promote the idea of study group. And we've created a platform where on Brightspace, by the way, where you guys can meet up on the platform and discuss problems. It's by discussing problems, that's how you learn. That's how you actually understand much better when you explain it to your friends. So we have all these options. Let's try to utilize them. All right. Okay, I'm going to call off the session. I've been talking the whole day today, but have a good one.